case, this time, what I'm gonna do is that I'm not going to use the toy list, but now I'm gonna use my own numbers. So for example, I can do something like 6, 7, 8, 9, something like this, okay? And then what I'm gonna do is I'm gonna print the array number 2, okay? Now you can actually see it right there, okay? So what I've just done is I just showed you 2 different ways of initializing a NumPy array, okay? So again, initializing, you're starting it, you're setting it up, okay? One way is that you create the original Python list, you put it into the NumPy array. The other way around is that you just set the number, okay? But you must use the square brackets, okay? To actually have that numbers, keep saved it inside the list form, all right? Any question at this point? Hopefully this is a warm up, okay? Nothing too complicated at the moment, right? Okay, next what we're going to do is we're going to test and see the homogeneous nature of the NumPy arrays. Okay, as I mentioned, the Python list, you can have many different types of data in a Python list, but NumPy is everything has to be the same, right? So I can do a list, okay, number only, okay, and I can do 1, 2, 3, and 4. I can do list mixed, okay, and I can do something like 1. Now that 1 is integer, okay, integer meaning a number. Now because of that quote, single quote, right? Now that is string, right? That is a character. Now next one, though I typed 3 there, okay, because I have the quote, it is still a string. It's not a number value, it's a character value. Okay, so there's a difference between the string and the number, okay? So here I have a mixture of it, right? Because the 1 and 4 are the integers, the numbers. 2 and 3, okay, they are the strings, the characters. So if I actually print the list number, okay, and then if I print the list mix, okay, you can actually see the commas, right? As I mentioned, clear indication that we to figure out which array, whether it's a Python original list, whether it's a NumPy list, the existence of the comma, okay, is one indicator. Okay, so you can see that they are the 1, 2, 3, 4, and 1, 2, and 3, and 4. So you can see that the array, the Python list allows you to have a mixture of data types. Okay, but let's actually take a look what happens if we do this. What I'm gonna do is copy this basically what I'm doing is just copying the number. As I mentioned, if I want to create the NumPy, what I do is I put NP, right? It's just a naming convention to keep things neat and ordered. So how do we initialize? NP dot array. How do we initialize the next one? NP dot array. And what are we going to put in? The list num only and list mixture. Okay. So next, what I'm going to do is I'm going to print them. Now I can copy and paste all this, print and NP list mix. So, okay, so before we run anything, so let's actually have a hypothesis. Like, let's try to predict what's going to happen. Now, the list number only, we saw is all 1, 2, 3, and 4, all the numbers. And then the list mixture mix is 1, 2, 3, and 4 with the two character set strings in the middle, right? Now, because NumPy array does not allow the mix of data types, okay, we can kind of guess that the NP list num only will have 1, 2, 3, 4 in the number. Now the 1, 2, 3, and 4, the second one, the mixture one, it will depend, okay? I think, but then yeah, I think the NumPy will actually make it homogeneous either by converting everything to the integer or to the strings. So let's see. Ooh, okay, there it goes. Okay, so the first one right there, okay, you can see that 1, 2, 3, 4, okay, they got rid of the commas, so they are all integers. Now you can see the next one right there, the MP list mix. What did they do? They converted everything into strings. Okay, so we had 1 and 4 number. Now the NumPy array does not like the mix. Okay, so they actually, NumPy array automatically converted everything to the string. Now, why string, right? Why? Because the biggest reason is because of the two, okay? Because this is not a number. This is a character. You actually spelled it out, right? So they actually change everything to this, okay? So you gotta be careful, okay? So when you're working with NumPy, make sure that you are you check what actually is in your own NumPy list. For example, when you created a list like this, and then you put it into the NumPy array like that. And if you're thinking, oh, because I have 1, 2, and 3, and 4 there, and all the numbers, right? You put it into the NumPy array because I'm playing with the number. You're expecting numbers to come out. It may not. Okay, so you gotta make sure that you check what you're dealing with. Okay. Any questions? Any problems? Anyone who couldn't get that NumPy installed? Everyone okay? Okay, I'm not seeing anything on the chat box, so I'm hoping, okay, you guys are all okay. All right, next 1.6. So we just learned about how to initialize the NumPy array. We learned about the homogeneity of the NumPy array. The next one is called ND array. So ND array is basically a multi-dimensional array. Sounds like if you're a big Marbles fan, it's like a multi-dimension, right? So it's ND array, it's an n-dimensional array. Okay, so n could be any numbers. It could be 1, it could be 2, it could be 3. Now we all live in a 3-dimensional world. If you add the time axis, maybe 4D, but basically the 3-dimensional world, right? But in the computer, inside the computer, it can go all the way up to, I don't know, 10,000, 100,000, depending on the number of. So if you imagine in your head, in your mind, Excel spreadsheet, you can actually consider the columns as the dimension axis. So if you have the X and Y, right, there's 2 columns. X column, the Y column. If you have a Z column, that's 3 dimension, right? So if you have, for example, what can I expect here? My age, my height, my weight, my salary, my number of family in my household. Like if all this, I just included 5 different data types. They're all dimension. So 1, 2, 3, 4, 5. That's a 5-dimensional array. Okay, hope that makes sense. Later on, when you go for the site surveying, you're going to measure different values, right? Now, each different values, okay, not, for example, the height, angles, and all that stuff, different variables, they are the dimensional axis. They are the columns, okay? So up here, we are working with what 1-dimensional. Now we can create 2-dimensional, 3 dimensions, and so on and so on. Okay, but let's actually keep things very simple. Okay, let's keep things very simple. So 1D is something like this. We saw 1-dimensional. 2-dimensional is basically we have a table, the rectangle-looking table. Okay, and 3-dimensional and onward, we're not gonna consider it for this session. Okay, so you can imagine it up to the 2-dimensional, the table looking like the metrics. Okay, so for the an array with a single dimension, okay, we can also call it a vector in the NumPy. Okay, now if you're working with 2 dimensions, you can actually also imagine it as the matrix. Okay, anything beyond 3, we can call it tensors. Okay, let me get my notes here. Okay, so let's try to initialize a 2-dimensional array. 2-dimensional array. Now, one thing that you need to be careful with is the brackets. Okay, so if you're using my notes, you're already seeing my notes there, right? So I wrote there what? Be careful with the brackets and commas. Okay. So I'll show you what I mean by that. So if I do 2D array, let's say I'm creating a NumPy array, NumPy 2D array. So what I'm going to do, how do you initialize it? NP array. Now, before what we did was we put a pair of square brackets, right? And what we did before was 1, 2, 3, and 4, just like that, right? We had all these commas. Now, what we're going to do within this bracket is create another bracket set, and I put 1, 2, 3, 4 there. I exit out from that bracket. Okay, so if you hopefully the font is big enough. Give me 1 second. Let me actually make it bigger. Sorry for that. Give me 1 second. Okay, just made it slightly bigger. Okay, so you can actually see the color difference here. That one right there is green. That one right there, to me, it looks like a purple or brownish. Okay, so you can see they're nested inside internal brackets. Okay, so what I do is between that brown and green, I put a comma there, and I put another bracket, square bracket there, and I could do like 5, 6, 7, and 8. Okay. I can make another one. I can exit out and then go 9, 10, 11, 12, something like this. Okay. And then if I do print, okay, there it goes. Now we can see that we are having that flat looking like the Excel spreadsheet looking like array. Okay. Now we don't only have one line of numbers, we have multiple line of numbers. Okay. So that's how we initialize a 2D array. Another name for this, again, is a matrix. Okay, matrix. Now, there's a very fancy function that we all should know how to use. Is, for example, we just created the NumPy two-dimensional array. Now, let's say we haven't printed this, okay? Well, what I just did is I just initialized this 2D array, and I haven't printed out, okay? But I'm wondering, how big, what is the size of this? Like how many rows, how many columns do we have? If you're wondering about that, you can do shape, okay? So this one is telling us, hey, there are 3 rows. So you can right away imagine the Excel spreadsheet where we have 3 rows of data and 4 columns of data, okay? 3 by 4, okay? How is it 3 by 4? Because we created 1 line, 2 line, and 3 lines, right? 3 rows, and each row has 1, 2, 3, and 4 columns, right? That makes sense? So we have that right there. So that shape is the function. Okay. All right, moving on to next. Okay. If you do have any question, again, do let me know. Now, next, what we're going to do is we are going to learn how to create quote unquote empty array. Okay. Now, we already learned how to initialize an array with specific values. Now, the next thing that we're going to learn is how to pre-allocate, okay? Pre-allocate a space, okay? Basically, this is like creating an Excel spreadsheet file. So later on, you can dump the values into it, okay? So basically, we're creating an empty bucket to dump the data later, okay? So we're going to create another NumPy, okay? Filled with zeros, okay? We call it, how do you initialize it? NumPy. All right, okay. So in this case, what I'm going to do is we're going to do 2-dimensional array, basically rows and columns, okay? And then we put 0, 0, 0, 0. So 1 row with 3 columns, another row, the second row with 3 columns, 3 zeros, okay? So let's take a look. Okay, there it goes, zeros in it, okay? And we can also take a look at its shape. 2 by 3, okay? Now, usually when I teach this for my students, okay, they actually have some question. Does anyone have a question at this point? Does anyone feel something is weird? Anybody? You're more than welcome to type it on the chat box. Something is odd. I intentionally made it slightly odd. Anybody notice something weird? What is the title of this sub practice 1.7? How to create what array? Empty array. Do we have an empty array? Who thinks we have an empty array, or who doesn't think we have an empty array? Okay. Okay. Well, empty means what? Empty. If you have a bucket that is empty, right? You have nothing in it, right? But then what is there you go. Inside have numbers. That's right. That's right. Inside have zeros in it, right? Why? Right? Zero, I mean, technically zero means we have no value, right? But then if you think about it on the other side, zero is also a number, right? It's not empty, right? We are filling the spot with zeros in it, right? So this is the thing, numpy array. So you got to be careful with this one. So we need to also remember this one, okay? Whenever you create quote unquote empty array, the spaces, okay? So if you are imagining, oh, okay, so I need to create 100 by 100 table, right? NumPy automatically fills it with zero. There is no such thing as emptiness in NumPy array, okay? There's no such thing as empty, okay? So it's always filled with a specific number. Now, we usually, computer scientists, programmers, we usually want to keep it as zero, okay? It's very simple to remember, okay? So that's why there are numbers, zeros in it. Now then, by the way, thank you all for responding, all right? What would happen if I tell you to initialize, start, or create an empty array size of, well, let's say 1000 by 1000? What are you going to do? Okay, so what we just did here is we just created a 2 by 3, 2 rows and 3 columns filled with zeros. Now, if someone tell you to initialize or set up 1000 rows by 1000 column worth of zeros, can you do it? Well, technically, of course, you can do it, but it's gonna take a lot of time. Remember the first lesson that I told you? Why are we using programming? To improve our productivity, right? To avoid unnecessary repetitive tasks, right? So in this case, we are not going to follow this convention. Instead, we have very fancy function filled. Okay, let's create another 0v2. Now, when we initialize an array before, we did MP array, right? But we can do zeros, okay? Now, what this is telling us, what this is ordering the programming to do is we're telling them, hey, we need an array filled with zeros, okay? Before MP array was like, hey, I need an array. I need a NumPy array, okay? And what that also is telling the program is that, hey, I need a NumPy array. I'll give you the actual values, okay? That's what that line, the MP.array is telling, okay? Now, MP.zeros is, hey, I need the NumPy array filled with zeros. The only information that I need to give out is the shape, okay? How many rows, how many columns. Now, for this, we're not using the square bracket. We are using, what happened? The parentheses, right? Round bracket, parentheses, the round bracket, okay? Not this one. Use this, okay? So in here, what we do is that we define the rows and columns, okay? give rows and columns. So how many rows? 1,000. Okay, let's actually keep the number small. Let's do 50 rows and 20 columns, okay? Just because you have to differentiate what is what. Run it. Okay, it actually created it. I haven't printed out yet. Oh, wait a second. Should be not the dot, but then the underscore. Okay, so that is right there. So let's try to print a lot of zeros. Okay, you can actually see the dot here because there are 50 rows, right? Because I said I need 50 rows. Now, if this environment are to print the 50 rows, it takes too much space. Output is truncated, right? So actually minimize the space that they're using. But hey, successful. Now let's take a look at the shape. As I mentioned, if the table, right, if the NumPy table, if the NumPy matrix is too big, usually printing it out takes too much space. So what I usually do is if the table, the matrix, NumPy matrix array, if it's too big, I just go with the shape. 50 by 20, hey, that's what I wanted. Okay. Ooh. Okay, so there it goes. Okay, so that's how you create the quote unquote empty, okay, array. Okay, and takeaway message here is that there is no such thing as empty, okay, must be filled with some kind of values. Okay. All right, next one. Now, what if I tell you, or what if someone tell you to create a NumPy array filled with numbers from 0 to 10? Now, this is an incrementing numbers. Sometimes you actually need to use this function. Basically, you want to do like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like you don't want to manually type all the numbers in. For example, if someone tell you, or if one of the equations that you're going to use later, not sure whether this will happen or not, but if in any case happens, right? For example, I have a number from 0 to 1 million, right? Like if you're gonna do this all the way to the 1 million, not feasible, right? So there is again the fancy function for this NumPy, let's say array. Okay, I would just say an array. How should I call it? A range of array. Okay, NP before what we did NumPy array. What was the next one? NumPy zeros. Now for this is NumPy a range of value. Now a range of value, you can actually provide many different options. In this case, I say, hey, from 0 to 10, okay? We'll see. So the option that I gave in here is 10. Now if I print this one right there, 0 to 9, okay? Does anyone know how you can interpret that value right there? What is it asking? What is that option? Okay, anybody? Put 11. 0 to 10 minus 1, that's a good answer. Yeah, put 11. If we want to opt the 10, yes, put 11 there. Now, what that option is saying is that we want 10 values. 10 values starting from the 0. Now, do remember this always. In computer, the number does not start from 1, right? Because as a human being, right, we learn how to count from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? We were not taught to count numbers from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But in computer, everything starts with 0. So that's why we ask for 10 numbers. It's giving me 10 numbers, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 numbers. Okay. So be careful. If you want, as mentioned in the chat, if you want up to 10, then you type 11. Okay. Then you get 10 right there. If you want up to 20, then you type 21. Okay. So be careful with this one. So this one actually, yeah, as you can see, just by specifying that number, for example, if I actually type 100, it's gonna go from 0 to 99. Okay, pretty quick, right? So if I actually go up to 1,000, Very quick. Up to 99. 999. Okay. So that is a range. Okay. So which functions have we learned? MP array, MP0, MP range. Okay. Yeah, I put some notes there as well. Okay. Okay, moving on to 1.8. Okay, concatenate and sorting an array. Now, concatenate is a concatenation. Like I don't want to use the term adding, okay? Because adding is a mathematical term. Now here the concatenation is you're putting two arrays together. You're putting two arrays together. You can imagine in your Excel spreadsheet, right? You have some data floating around. Let's say somewhere same page, but it's somewhere around. You have another chunk of data. If you want to put all of them together, what you do, you actually drag and drop, right? Drag and drop, right? Not drag and drop. You actually select and then you do Control X cut, right? Cut and then you go to the cell that you want to paste it, and then you do Control V, right? So if that sounds familiar, almost the same concept. Okay, so here what I can do is I'm gonna create an array, MP array called A, and let's actually have some values in it. Now I'm gonna define my own values there. Now next one is a B, is another MP array with values, with values 5, 6, 7, 8. Okay. Now if I actually print A and B separately, you can actually see them separated. Okay, they're not together, okay? So if I print A only, we're only seeing that line. But what if we want to put them together, okay? So basically, what if we want to make a two-dimensional array? We want the rows and columns, right? Right now, just with this, we only have rows or columns, right? There's no, you see what I mean? Because it's just a single line of value. It's not a Excel spreadsheet, okay? So what we can do is I'm gonna do AB equals MP dot concatenate, okay? And inside, I'm gonna put the round bracket, and in there, I'm gonna put A and B inside, okay? And let's try to print it up. Ooh, so we have actually combined the numbers together, but in a what way? In a what way? Have we haven't put it in up and down the stacking wise, but we actually put it in a horizontal way, right? We put it on the horizontal way. Now, if we actually want to put it in a stacking way, up and down, not on the horizontal, one-dimensional way, what we need to know is we need to know the concept of something called axis. Okay, so let's take a look here. So let me do it here then, okay? So what if I do like this, axis equals 0, okay? So when I do axis equals 0, when I actually print AB still as is, but what happens if I do axis 1? Error, ooh, why? Okay, so we're gonna figure that out, okay? So there is a concept of axis determining exactly how we are going to concatenate the arrays together. Okay. So let's go to next array, next cell. So next one, I'm gonna say MP dot array. Okay, and here I'm going to put 1 and 2, and 3 and 4, and Y I'm gonna put MP dot array and 5 and 6. Okay, and what I'm gonna do again here is I'm gonna cover them. So it's two-dimensional array. Okay, so here and then for this one as well. Okay, so you will see it here. If I print X, okay, you'll see 1, 2, 3, and 4. If I print Y, you will see the 5 and 6. So let me actually, no, oops. print like 5 and 6 right there. Okay, so you can actually see the image below. So basically the 1, 2, 3, and 4, they are the X. 5 and 6, they are the Y. Okay, now we're gonna play around with this, okay, and do the Z equals NP dot concatenate, okay, and then I can do X and Y, and there is an option called axis equals 0. Now, what does axis equals 0 do? Okay. Now, when I say, hey, I want to concatenate these two on axis 0, means that I want to expand on the rows. Okay. Now, axis 0 means rows. Okay. I want to increase the rows. Now, if I say axis equal 1, okay, this will actually create an error. It creates an error because this one is telling the columns. I want to expand on the columns. Now, if you look at the first example here, concatenate on axis 0 means you're adding rows so that the Z, right, on the right side of the blue arrow, 1, 2, 3, and 4, 5, that table looks okay. That table looks valid. Now, if you look at the next example where we have 1, 2, and 3, and 4, and 5 and 6, which is a Y. Now, if I tell I want to expand on columns by specifying axis 1, the result is this 1, 2, 3, 4, 5, and 6. Now, something is odd, right? Because that bottom area right there, basically there is missing values. Now, if you remember all the way back up when we discussed about the NP zeros, right? Numpy does not like the emptiness. It's not gonna allow you to do that. Okay, so we have to have some numbers, but what did I just ask here? Concatenate on the column wise. I want to expand it on the column. It's not gonna like that because there are empty spaces. Okay, so that's why all the input array dimension except for the concatenation axis must match exactly. Okay, so very complex error, right? But basically what it means is that, hey, you cannot do that, okay? Because the shape looks a bit weird, okay? So in that case, if you really want to expand on the column axis, column-wise, on the horizontally, there is something called transpose. That 5, 6, you can actually flip it. The 5 goes up, 6 goes to the bottom. You can actually do that, okay? So how is, let's say, let's copy this. Okay, I'm gonna go down here. And then we need to transpose the Y, right? Because the Y was having some issue there, okay? What you can do is, I'm gonna call it YT, Y transpose, okay. Y transpose, okay? Just Y dot T, that's it. Pretty simple, right? That capital T dot T is telling, hey, Y, you need to flip, okay? And here, I cannot use Y because Y is horizontal. YT should be flipped. So I just put YT there. Should be okay. There it goes. You see the 5 and 6 attached right there, just like the image on the top. Okay. Now, what this is telling you is whenever you're playing with NumPy, the values, right? For example, when you go site surveying, gather all the data. Now, you always need to have an expectations. Okay, you cannot just blindsidely go there, NP array, just let me just create it, right? Dump the data, error happens. Why, right? Cannot do that. Okay, always read your data, right? Make sure that you understand how many rows, how many columns, right? And then when you're combining it, you also need to take a look at like exactly what you're doing. Are you expanding the table onto the column wise? Are you expanding it on the row wise, right? Do you have the shape that is acceptable? For example, when you concatenate, is my table look okay, right? So basically you need to check all this stuff, okay? Right, that's the concatenation. Next one is called not sorting, sorry, the type of sorting, okay? Sorting on elements, okay, using the NumPy array. So sorting, you sometimes need to sort an array, for example, as computer science teacher, sometimes what I do is I grade when my students take an exam, and if I actually use Python programming to automate some of the grading schemes, sometimes I get the final marks. And what I need to do is actually I need to sort the final marks, in a standing or descending order. Usually if that's required, I usually use this function. Okay, so let me first come up with the NumPy array. I'm gonna have my own values, 3, 7, 4, 6, 8. Okay, and if I print the array, I just get what I just created, right? Not ordered, which is all mixed up. Now, if I want to sort it, I call it sorted array. You can just do np.sort. Okay, and you're just telling it, hey, sort that array, the ARR, okay, to sort that array. And if you print the sorted array, see, you can actually see from 1, 2, 3, 4, 5, 6, 7, 7, 8. Okay, so before it was all mixed up. Now, because I told them to sort it, there it goes. Okay, sorting part is pretty straightforward. Now, as I mentioned, a lot of these functionalities, okay, for today, okay, you're just looking, if you're doing a practice alongside with me, that's the best case. If you're just listening or watching, okay, the takeaway message for today is that you know what kind of functionalities are out there, okay? There's big difference between you knowing that these functions available versus not even know what's out there. Okay, so NP array, right? What is it? NP.zeros, what is it? Like, why do you need the NP.zeros? NP.concat, right? NP.sort, right? All that's, right? Basically, you need to know that they do exist, the arrange, right? First, you need to know that they exist, and then once you know, then you can put them into a practice. Okay, so sort. Ooh, okay. 1.9, things will get slightly ugly, okay? But conceptually, it's quite straightforward, but then implementing it may take some effort, okay? But it is quite important, okay? The next topic is called indexing and slicing, okay? Now, indexing and slicing, hopefully you already did this more or less on the Python list. If you did, that's good, okay? If you haven't, then here will be your first exposure to it. I mean, if you already worked with the Python list, more or less, you might have some ideas on how to access the data, right? So for example, again, there are example here. If you have a data, right, a list of data 1, 2, and 3, right? When you want to access the first element, you do the data square bracket 0. Second element is 1. The next element is 2, and so on, right? Because everything starts with 0, right? The first element index is 0, right? The ID given to it is 0, right? And there are ways that if you want the 1 and 2, you can do the 0 to 2, right? The 2, right? From 0 to 2, we don't get the 2, okay? We don't get the 2. We get the 1, we get to a point that is 1 before that, right? So basically, if you do 0 dot dot 2, that means we go right up to that 2, right? So that's something that you need to be careful with. Here, the data starting from the index 1 all the way down, dot dot 1 dot dot, nothing behind, right? So that's the slicing, okay? So this is an important concept. Now, we can actually do something very similar with NumPy array. Now, you might wonder, Prof, like, why are we learning this slicing, indexing, right? Because when you get your survey data, right, you will have likely you will have columns of data. Now, if you need to apply an equation, for example, you grab column A and column C, and then you need to and you have a lot of rows, right? Like, and then when you need to combine these two, when you need to do a mathematical task, if you need to, for example, if you need to do an addition between these two columns, you need to grab the column A and column C. How, right? This is how, right? So np.array. So we'll start it with a very simple one, okay? So just like the one example above, so basically we are just creating the data, right? Let's print that out. 1, 2, 3, just like that, okay? Now, if you want to grab, let me print it. The very first number, it's like that, 0, okay? Now, when you do the data, the square bracket 0, you're not, when it's printing it out, you're not getting the square bracket because you just grab the highlighted value and you're just printing that. Now the square, because the square bracket means you're dealing with an array, a list, okay? So you just got that value. Now, if you want to do 0 to 0, from starting from the 0 all the way just right before the index 2, you do that just like that, okay? So that's the accessing the numbers. Now, if I want to do something in 2D, likely, two-dimensional metrics, the rows and columns. So I create another one, np.array, and I can do something like 1, 2, and 3 and 4. Be careful with the square brackets and comma, okay? 5 and 6. Well, I sometimes also make mistakes if I'm not paying attention. So here we have that. Oh, how about we expand this a little bit? Let's actually make it 3 columns, shall we? Just like that, okay? 1, 2, 3, 4, 5, 6, 5, 6, 7. So we have 3 rows and 3 columns, right? So in this case, if we want to access, we can do something like print data, do 2, 0. So in this case, what we're getting is 5 because that right there is pointing to the rows, okay? So this one, let me actually put a comment there. Data is row and column. So we said, I want to access the row index 2, not the second one. This is not the second, I mean, this is the second, but index here is 1 because everything starts with 0. That's index 0, index 1, index 2. So that row, data square bracket 2, will give us an access to the second row. And then what did I say? I want the 0 index column, which is the first column. From this row, what is the first value? 5. That's why we get 5 there. Now, if I put, okay, the index 2 and 1, then I'm accessing this guy right there, and then I'm getting the 6. Okay, so let's do that. 6 right there. Okay, so this is how you get individual value from that table. Now, if you want to grab the entire row, okay, you can do something like, so this one will be entire row. Wait a second, sorry. Let me actually put this to a silence. Okay, and I'm trying to make it a bit nicer too. Okay, there it goes. Okay, and then 1. If I want to get this guy, that's 0 and 1, just like this, just like that. Okay, so what this is saying is that, hey, I want the index 1 row. That's index, that right there is index 0 row. This one is index 1 row. Okay, and what did I say? Dot, dot. Okay, that column means I want everything. Okay, that means I want everything. Okay, so in this case, I got everything that I want. Okay, now what if I want the columns? What if I want 2, 4, 6? Okay, let's try that out. Data. So in this case, what we need, okay, is we need entire row. That means I want every row, dot, dot. But which column do we need? 0, 1, 2. So we need 1, right? Ooh, something interesting happened. Okay. All right, so when we did data 1, the first index row, I want every column. I got 3, 5, 3, 4, 5. So there you go, 3, 4, 5. Now this line of code here, it says I want every row, but the index 1 column. So I want every row, but the index 1 column is 2, 4, and 6. We got 2, 4, and 6. Hey, but not in this order, right? 2, 4, and 6, not in this way. Okay? So we still got that value, but in a flat manner. Okay? Now, when you grab that row, or sorry, when you grab that column, when you take it out, the 2D shape goes away. Okay? The 2D shape will go away. You will have a single one-dimensional array values. Okay? I can kind of tell this concept might be slightly confusing, but okay. But you need to actually digest this later on when you're doing your own self-study reviewing of the contents. Make sure that you revisit and then make sure that you understand why this shape of values change. Shape here means the dimension, whether you're looking at the matrix 2D, or whether you're looking at a just list of value. 2, 4, 6, we just grab the list of value. That's why we see it just flattened out like that. Okay. You can also select values from your array that fulfills a certain condition. Okay. So for example, if I do the name Numpy array range of value. So if I want 10 of them. Okay, 10 values. So if I print A, right, 0 to 9. Now, if I want less than 5, okay, that's what, 0, 1, 2, 3, 4, right? If I want less than 5, I can do something like A is what? A is that Numpy array. So from the A, okay, or let's have a better name, MPA, okay. A sounds very careless. So from that MPA, I'm actually getting specific value. So I use square bracket. And inside here, I put the condition that I'm looking at. I want everything that is less than 5. Okay. So if I print this, there it goes. Okay. So I got that's less than 5. If I do less than 7, okay, it's no longer less than 5, but you see what I mean. Yeah, there it goes. 0, 1, 2, 3, 4, 5, 6. Okay. Because the variable name says less than 5, let's just keep it that way. Okay. You can also do something like 5 up, 5 and up. Okay, so MPA, you put condition that you want, so should be greater than or equal to 5. Okay. You can try to print them 5, 6, 7, 8, including the 5, right? So basically, this is how you select a subset of value from the original array that satisfy the condition that you provide inside the square bracket. Okay. You can actually see from the notes that I shared with you guys that there are a few more. Well, yeah, there are a few more, but you can actually take a look at it later when you're doing your reviews. Basically, there are like divisible by 2, right? And you can actually put multiple conditions to it as well. So, but then this is the basis of that. Okay, the next one is the basic array operation. Now, something that is very practical for you, okay, which you actually need to do to compute different values. Like you need to do addition between different columns. You need to do a different subtraction between different columns, multiplication, divisions, and all that. You can do that, okay? So if you have a data 1 and 2, the 1s and 1, 1, imagine that these are the arrays. If you need to do an addition between those two, you can actually do the addition. Basically, the first here, the first values, they're added to the answer 1 plus 1, 2, 2 plus 1, 3, right? Subtraction, same thing. 1 minus 1, 0, 2 minus 1, 1. And you can actually expect all that to happen. Now, how do we do this? Okay, we are gonna create the data array. Okay, now hopefully by now, you know what that NP array means now. Okay, we're creating the NumPy array. Now we're gonna create the ones From the notes, you will actually see the ones, okay? Just like the zeros, you can also actually create the ones, okay? But for this session now, I'm just gonna do 1 and 1, okay? For the simplicity's sake, okay? So we have the data, and we have the ones, okay? There it goes. So we do have that. Now, if you want to do the data plus ones, you just do it like that. Simple as this. Okay, you see the 1, 1, they're added, 2, 2 and 1 added, 3. Okay, if you do minus, okay, that's simple. Okay, if you do multiplication, it's that one, the star. Okay, division, if I remember correctly, that was a division. Yeah, that was a division right there. Okay, so add, subtract, multiplication, and division. Okay, so you can just do it that way. Now, this one right now is basically doing the computation and then printing it right away. Now, if you need to save the results, you can do like this. Basically, that result is saved, right? That result 2 and 3. Before, we haven't saved it. We just print. We do the math, we just print. We never saved it anywhere. In this case, we do the math, we save the result into the result variable, we print out. Okay, so this is how you save it. Next one is a summation. We can do something like a equal np.array. Okay, and I can create 1, 2, 3, and 4. Now, summation is basically you're running through the entire value, you're adding them all together, right? So this one pretty simple as well. So let's do summed a equals a, not np, okay? A dot sum. In this case, you need to put that round bracket, okay? And then you can print summed 10, okay? 1, 2, 3, 4. If you add them all up, that's 10. Okay, one more, okay, one more. B equals np.array. So let's create a two-dimensional array, 1 and 1, and 2 and 2. Okay. And let's try to print the B. So there it goes, 1 and 1, and 2 and 2. Now you can imagine when you're playing with Excel spreadsheet, the summation can also happen on the columns and on the rows. Now, depending on what you need to do, right? If you need to sum all the values on a column, you should be able to do that. If you need to sum all the numbers on the row, in a specific row, you should be able to do that as well, right? So how? So let's do the rows summed, okay, and do column summed, something like this, okay. And what I can do is I can do something like b dot sum, okay. Before we just do it, right? We just saw it like that, right? But we're not gonna end there, but we're gonna specify the axis 0, axis 1. Okay. Now remember the concept of axis, right? When we are concatenating it, right? We were like axis 0 was we were concatenating it on the rows, right? We are expanding it on the rows. Axis 1 meant we are expanding it onto the columns, right? So let's see what happens if we do this. Ooh, okay. So when we did row sum, okay, now that term row is not technically correct. So this is a very, you might easily get confused. Here it says axis 0. So we're looking into the rows, right? But what we're doing here is that, for example, we're actually summing it, you following the rows. Now, if you actually follow the rows to sum, what are you summing? You're summing that column specifically, right? When you're doing a summation, if you start from the first row and then because I said axis 0, if you're going through the rows to sum, right? You're summing what? Entire column. Now, if you're summing through the axis one, which is column, let's say you start from the very first number and then you're actually traversing through the columns, right? You're actually summing that specific row. Okay, does that make sense? That's why when we did row summed, we get 3 because 1 plus 2, 1 plus 2, 3 and 3. When we did axis 1, we get 1 plus 1 equals 2, 2 plus 2 equals 4. Okay? Technically, this is summed, a column is summed. Okay? A row is summed, right? So you gotta be very careful, okay? You need to understand what that axis equals 0 actually means. Okay? Next one is min max. Sometimes you need to find the min max values. So for example, let me go ahead and grab that A, put it right there. You can actually get the mean value. Okay, mean, of course, 1, 2, 3, 4. Mean is 1. You can also do the max. Max is 4, right? So that easy. Okay. You can also given a 2-dimensional array. So let me go get it. Let me actually make it. Okay. Copying and pasting to save some time. I just made C, array C with the first row, 1, 2, 3, 4, 1, 2, 3, 4. The next row, 5, 6, 7, 8. Okay. Now if you print the C, you can actually see that these values are right there. Okay. Now, again, just like what we saw from this, where we go? From this cell when we were doing a summation, right? So when you're looking for the mean and max, you can also specify whether you want to do it on the rows or columns. Exactly same concept. So something like print C, which is a 2D. I'm looking for the mean on the axis 0. Okay. You can also do something like, hey, I'm looking for the minimum on the column axis. Now we need to actually have an expectation, okay? So when you're looking for a minimum value, scanning through the rows, meaning that 1 versus 5, which one is smaller? 1. 2 versus 6, which one is smaller? 2. 3 versus 7, which one is smaller? 3. 4 versus 8, which one is smaller? 4. So this one, we're scanning through each row, okay? And then we're actually figuring out what is the smallest value. Now, this case, we are scanning through the columns. What is smallest? 1. 5, 6, 7, 8. What is smallest? 5. Okay? There it goes. Okay? Again, the concept of the axis. Okay? Now, understanding the concept of the axis might be very, very important. Okay? All right. Any questions? Any technical difficulties at this moment? Okay. I'm keeping my eyes on the chat box. So if you do have any questions, just feel free to type it on the chat box, okay? All right, moving on. 1.11.11 now working with an actual mathematical formulations. Now, I brought in a formula called mean square error. Okay, this is a very famous equation that we use in AI. Now, for engineers, for you guys, when you go ahead and do the site survey, you will have your own equation. Okay. Now, this will be an example of how to translate this equation into Python. Okay. Now, I actually color coded everything here. So what you see here is a 1 over n. N is the number of data that I will have. N is the data. I is the index. Okay. We have summation starting from the index I1 all the way to the number of elements. Basically, that actually right away tells us that we're scanning through the entire elements that I have. entire data, okay? And I have some prediction value, okay? And then I have some predictions and labels, the Y and Y, okay? Basically, I'm gonna do some subtraction. Now, after I do the subtraction, what am I doing here? I'm actually squaring it, okay? And then I'm actually summing it all up, okay? So here is the equation translated more into the Python language format. I have 1 over n times numpy sum. We learned about the sum, right? And then we have another one, np square, okay? And we have the predictions and labels, okay? Now, if you recall back from the very beginning of today's session, that I mentioned that we are using numpy because of why? Because there are a lot of pre-built, okay, functionalities that others have already made for us, okay? All this square, the sum, all this, everything, someone else already made it for us. Now, you just need to know that they do exist, and you just need to know how to use them, okay? So what I'm doing is I'm creating the predictions and labels. You can see that prediction, the red one, the purple one, labels, okay? Just this will happen to you guys as well, is that you will have a list of values. For example, whether you got it from the column, you got it from the rows, depending on how you get it, you will have a list of value called, you can name it whatever that you want, okay? Height, angles, okay? Depth, right? All that. The predictions, labels, I call it the predictions and labels. These are the columns, okay? These are the data that I collected. And with this, what I do is I'm gonna follow that equation right there, okay? One thing that I also need to figure out is n is the number of data that I had. So predictions size. So this size function will give me the number of data that I have. So we have 3, so that will give me 3. Okay. Now what I'm gonna do is I will have the A term is n 1 over n. Now, because I'm actually having that green part is the A term, the summation part is a B term. So I have that right there. Of course, if you don't want to have that A and B term, you don't need to have it. Okay. I just did it just because I want to keep it organized. Okay. And P dot square and predictions minus labels. That easy. Just I'm already almost done. Okay. So error equals A times B. That's it. Okay. Now, what did I do? I just have this term, but if I don't want to do this, then I can just exactly follow that right there. Okay. Well, let's actually keep it consistent. Okay. Let's actually do it this way. There it goes. Okay. That's simple. All the concept that we just learned just before, I put everything here. So we initialize the array, right? There was the okay, so we learned this just now. The array minus the array, right? The addition, subtraction, multiplication, and division, we actually saw it before. If you have a numpy array, you can just do it like that, okay? The sum, we learned it, np square, I just mentioned it now. You just need to know that these things actually do exist, right? Everything just, right away. Translates very directly. Okay. Any questions? Okay. Now, due to the amount of topics that I need to cover, we're not gonna get any rest now, because the beauty of having the Zoom session is that you can just have your earplugs, the AirPod or the earphone plugged in. If you need to go and drink water, you can actually go ahead and do that. If you need to visit toilets, you can also do that. Make sure that you're muted. Okay, I cannot get up, but you guys can all do that. All right. So I'm gonna push forward. All right. Okay, so 1.12, plotting arrays with matplotlib. Now, matplotlib. Now, this is another very nice function, function that we have in Python to actually allows us to visualize, okay, the numbers. Like in Excel spreadsheet, right? The Excel spreadsheet also has a graph function, right? So you can actually grab entire columns or entire rows, and you can actually pump out the graphs, the visualization part. So you can actually do it here as well. Now, there is a library called matplotlib. So what you should do is if you're using conda install matplotlib, and it was like a yes. Okay, if you're using the pip, it's a pip install matplotlib. Now, of course, I already have it. Okay, so if I use it, it shouldn't be any problem. But if you don't have it, go ahead and install it. Okay. Now, assuming that you guys are importing it or downloading it right now, I'm gonna take it slightly slow. Okay. Now, of course, just like the Numpy, right? Once you download it, once you install it, you need to import. So import matplotlib. In this case, not that, okay? But we're gonna do matplotlib dot python plot pyplot, okay? And we're gonna give a name of PLT as a plot, short. It's a short wording for the plot. Okay, let's run it. Okay, I have no issues. Import. Okay, so I have a yellow line. Yellow is a warnings. Okay, so it's not actually error. You can still run it. There's no issue for that. But if you want to solve it, you can try to do that. But I don't mind having it. Okay. So once you imported it, we can do the MP array, and I'm gonna create a list of value. Let's say 5, 4, 3, 2, 9, 10. Okay. So we can kind of imagine, these values. So we're gonna plot this. We're gonna see something like a V-shape graph. So if you print it, we see the values like that. To plot it, we do PLT. PLT is right there. We're actually calling, hey, I need to use a matplotlib. Okay, I do dot plot. Okay, and then hey, plot this. And then if I do it, I see that right there. Okay, that's how you use the matplotlib. Of course, you can also plot multiple lines. Okay, but this is the basis. Okay, of how to use a matplotlib. Any questions? Anyone having any issues? Okay, now's the time because I'm here, right? Of course, Prof. Kim also will help out if anyone having a technical issue. But if you have any issues, if you have any uncertainties, if anyone wants me to repeat any part of this, again, feel free to type it on the chat box. Okay. If no one mentions anything, that means I'm assuming that everyone's doing very good. Okay. I'm just gonna push forward. Because that was the end of the Numpy. If you remember, there was a Numpy and data frame, right? So we just finished the Numpy. So I'm gonna push forward to the data frame unless there's any questions regarding the Numpy. Going once, going twice. Okay, so moving to the data frame. So we just learned about the NumPy. NumPy was number Python, numerical Python. The objective of the NumPy was to help us use those mathematical stuff. Okay. Yeah. So basically, we learned NumPy because we wanted to have an easier time dealing with numbers in Python. Now, the next one is data frame. It's called Pandas data frame. I usually call it just a data frame. Okay. Now, why do we need to know how to use a data frame? It's because the data frame is a fancier version of NumPy. Now, what do I mean by fancier? Okay, is when we create a matrix, two-dimensional matrix, the rows and columns in NumPy, do you see the column titles? We don't. Do you see the row indexes column? No, we don't. Okay, what we see is just numbers. Okay, give me 1 second. So, for example, when we create, this is an Excel spreadsheet, okay? So when we create Excel spreadsheet, what we see A, B, C, D, right? But then what we usually sometimes do is we do something like height. This is a height. This is the age. This is the weight, the BMI. Some health score, right? We actually do this, right? And then we do something like this is for Homin, myself. This is for Dr. Kim, Prof. Kim, and this is for someone else. Okay. So you can actually have this fancy style. This is what we usually do with the Excel spreadsheet. Now, if we look at NumPy, do we have that? No, we don't. Okay. So to have that fanciness, we use Dataframe. Okay. So we use Dataframe. Now, of course, on top of that fanciness, we actually do have a few more advantages that are listed down here, like easy handling of missing data, right? Basically, if you have a hole in your data, for example, yeah, someone said something? So for example, if we have something like, let's say I weigh about 83 BMI, I don't know, health score, well, let's just say 100. So for example, if we have this type of data, right? Let's say my age is missing, my BMI is missing. If we apply some mathematics, we can actually figure out the BMI. I'm not sure what that score is like, but so basically we can have that. But age, if I have not provided my age, that is a hole in my data. Now, what the data frame is saying, if you have a missing data, they're just gonna fill it in for you as NaN. So basically not available. It's not there. Okay, so they actually have that fanciness of filling those numbers in for you. Okay, it's not like filling in the actual number, but this is just like, hey, there's no value. Okay, but there's an indication. Okay, so that's one fanciness. That's one advantage of pandas. Okay, column, just like the Excel spreadsheet, columns can be easily added in, added out. Okay, so there's a lot of advantages of using pandas when you're dealing with these tables. Okay. So in data frame, pandas data frame, as we saw from the Excel spreadsheet, there are columns and rows, just like the NumPy. Okay, just like the NumPy. So let's take a look. Okay. Now for this, if you want to use it, of course you need to install it. So pip install if you're using pip, pandas. If you're using conda, right? Conda. Okay, I'm using pip most of the time, so conda install pandas. Sorry, I actually had a typo right there. Okay, so if you do that, you'll be able to install it. Okay, I'm gonna take it a bit slow because I want to make sure that you guys have it. Okay, now if you're able to, please do the practice. If you basically do the lab this with me. Okay, so you at least get your hands-on experience. So once you import it, you do pandas as PD. Ooh. Oh, sorry, typo. There it goes. Okay, so you import it, you give a nickname as a PD for the pandas data frame, PD. Okay. Now, for the pandas data frame, NumPy, I usually call it NumPy array v1. Like I had that NumPy, the prefix, right? Now for the data frame, I do df prefix. So I do. Let me create the data frame, the toy example. So in order to initialize, to set it up, the data frame, I do PD. I'm calling the pandas data frame dot capital letter D. Okay, data capital letter F data frame. Now initializing a data frame, it takes a bit more effort. Okay. Now the good news is that there is very small chance that you need to initialize the data frame from the scratch. For you, usually what's going to happen is that you will have the Excel spreadsheet first, okay? And then you will actually import this into the data frame. That's what usually happens. Okay, we're going to take a look at that example later, okay? But to learn how to initialize this, okay, we have the round bracket. you use a curly bracket, not the square, curly brackets, okay? You provide the column name, that's the name for the column. Okay, now this, as I mentioned, is quite tricky. Now, under that column, I'm going to have a value of, for example, Alex, Ben, and I can do some like KC, something like this. Okay. And again, be very careful with where you put things. Now I can do age, column, square bracket, 19, 20, 21. Phew, okay, no errors. And then I can do print, df, toy. There it goes. Okay, as I mentioned, fancy. Okay, we have the column titles, name and age. We have the index 0, 1, 2. We have the index 0, Alex, 19 years old, Ben, 20 years old, Casey, 21 years old. Now, one thing that I also want to show you, if you actually get rid of the print, you actually get even fancier table. Okay. Now, actually, it depends on how you want it. Okay. I usually have print like that. Okay. Okay, so next one thing that we can also do is, let me put one code here. We can actually do a few different things. For example, if you have numbers, you can actually look for the average, you can look for the standard deviation and all that. So let's take a look. So from the DF toy, I'm looking into the age column. And if I want the average, it's the mean. You see the mean, median? The mean is actually the average. Median is a median, right? You also have the standard deviation. STD is the standard deviation. You can also do the var. Var is the variance, right? So if you actually do the mean, you can actually get it 20 years old, right? Because 19, 20, 21, the mean, if you sum it all up, divided by 3, that's 20. Okay. You can also do the mean, okay, 19 years old, right? You can also go for the variance, 1.0. Okay, so just like the Numpy, Dataframe also has some fancy functions like this. Now, again, you need to know that they do exist. Okay, so there it goes. Now, what we're going to do is, let's say we have this table, right? This data frame. Now, let's say what should we do if we want to save this into a file, into a CSV file, right? So to save this, very simple, dot to CSV. That's it. CSV is a column separated value. Okay. So if you actually go to here, I actually have it right there. Okay. So if I actually double click it, it will open up the spreadsheet like this. Okay. So you can actually save it here. You can also open this in Excel. Second, just like that. Okay. You can actually do it like that as well. Okay. Now we want to save it. Now, what you need to do is dftoy to CSV. Now you just need to specify the file name. Okay, I'll call it new toy.csv. Okay, run it. And let's go to the folder. So this is a folder that I actually have this class v2 Jupyter Notebook file. If you go all the way down, there is it. There's a new toy.csv. So if I open it, there it goes, Alex, Ben, Casey. Sorry, the font is quite small. You can actually see the table like that. Okay. So that's how you save it to the CSV file. That easy to CSV. Okay. Now then, how do you read? How do you read? So this is very important example. Okay. So anyone sleeping, anyone tired, wake up. Okay. This is the example that you should know. Okay. For your survey examples and using the program. Now, how do you read? Okay, so let's say I had another example, right? So this one, A, B, B, C, C, right? The Alex Ben case is the one that I made and saved it. Now AABB, that one is the one that I had it before. Let's say this is your survey data. Now to do this, I create ABC. So that's the data frame name. You can come up with any names. Okay. You do pd dot read CSV. That's it. And what you do is you just need to provide the file name. That's it. Run it. Print. See that right there? Data is inside. That's simple. Okay. Basically, to CSV is you're saving your data frame to the CSV file. If you have your CSV file, you can actually read it right away. Okay. And then all the column title, all the information that you had before will get saved. It will get imported. Okay. You're not just getting the value. You're not only getting the value, you're getting the column titles as well. Okay. Now, once we know how to save and read the CSV file, next thing is we need to know how to access the columns. Now, from that toy example, we had the ages, right? So let's say the new, wait a second. Yes, toy, copy. From the toy, we had the age, right? And we also had the names. So basically, you're getting the columns by specifying the column name, okay? Sorry to say that easy so many times, but it's just that easy. Okay. Once you have the data frame, and if you know the column name, if you want to grab the entire column, you just give the column name just like that. So you get the ages, you get the names. Okay. Now, if you want both, okay, if you want both, let's say you have, if you imagining that you have 10 different columns, right? You have very wide table. Now, if you want to grab a specific columns out of it, in this case, I want the age and names only, you can do something like df toy, okay? Inside the square bracket, have another square bracket, okay? And then do age, comma, name, okay? And then you can print them out. Oops, I have one more. Okay, you can actually print a specific columns. So if imagining that we have like a BMI and all that, you can actually attach the columns that I want more and more. Okay, you can actually do that. Okay, but now, right now, we only have we have a very small one. Okay, so we're just gonna keep it simple for now. Okay, and of course, you can get your Prof, can you return to 2.4? Yeah, sure. 2.4. There it goes. Do you have any specific questions on 2.4? Or just want to see it? Yeah, so that's it. Oh, you got an error. Edit it. You got an error when you edit it. What is the error set? Can you actually copy the error and paste it on the chat box? Oh, because this one, that one. You're missing this one. You have to run this cell. Basically, it says that means you haven't imported the pandas yet. Okay. Yeah, I'll keep my eyes on the chat box. So if you still have the issue, let me know. Okay. So moving on, next is the rows. Okay. So we can get the columns. Now we should be able to get the rows, right? So let's print our toy example first. Yep, that's the example that we have. Now you can actually get specific rows using a specific condition. So for example, on the age, if you want people who are above 20, ooh, okay. Give me a sec. Let me actually silence this guy right there. Ooh, what we have here is false, false, truth. Interesting, right? So what happens is like this option right there on the age, so we had 19, 20, and 21. 19, 20, 21. Only the last one satisfied that condition, right? So that's why it's actually giving me false, false, true. But that's not what we want, okay? What we want is actually that rows, right? So in order to do this, what we should do is this. Above 20 years old, okay? We can do df that toy. From the df toy, I get square bracket, copy this condition, paste it into the bracket, okay? And then print. Hey, right there. Okay, so if I go back up, we had 19 Alex, 20 Ben, 21 Casey. Now I want the person who's above 20, which the Casey is the only case here. So with this condition, I get Casey. Okay, so this is getting a specific row using a specific condition. Okay. Now there is a function called eloc, index location. Okay, so this one allows you to access a specific index rows, okay, using numbers. So for example, with the numpy, okay, with numpy, where's my np.array, np toy. For example, if I had some values in it, I could do something like this, right? This will get me the first value, right? So, or if you have two-dimensional, this actually 0 means the first row. And if I do like this, that means index 1 elements, right? So if that sounds familiar. So we could do this with the numpy. Now with Dataframe, we cannot do it directly. We have to specify the integer location, index location, okay? So in this case, what we can do is something like this. Ooh, index error. Okay, because we are missing. No worries. Oh. Slice two. Oh, okay. Understood. Okay. Okay. The reason why. Okay. Please give me 1 second. Let me copy this. The example that I had previously was I actually had a bigger table. Now, because I'm keeping things simple. Okay. Now, in this case, what we're seeing is that this is a row and that's a column. Okay, just like the NumPy. Now, that is an index 0 row, index 1 row, index 2 row. Now, index 1, okay, index 1, we're actually grabbing this, okay, and then we're actually telling, hey, which value that I actually want to get out of it. So in this case, if I do 0, I get Ben. If I do 1, I get 20. Ooh, why is that? Because we have the 20 front, Ben at the back, right? When we do 0, we get Ben. When we do 1, we get 20. Now this has to do with how the data frame actually manages the internal. Where did it go? The internal, the printing out. So if you actually go all the way back, how we initialize it first. 1 second. Okay. Now this below is the original initialization. Okay, this was our original initialization. So we actually had the name first and age. Along the way, because we were playing around with the values here and there, the column order may get mixed. So it's always wise to refer back to our original setup. Okay, so this was our original setup. So according to this, right, we get Ben, right? Because that's the first column, that's the index 0 column. Now, if I set 1, we get 20 because that is the index 1 column. Okay, so ilog, integer or index location. Okay, because the data frame does not allow a numpy style. Okay, data frame, if you want to use the indexes to get value, this one, ilog. Okay, all right, any questions? We are at our final example now, 2.6. Before I dive in, any questions? Okay, I'll keep my eyes on the chat box. Okay, so if you do have questions, let me know. Now, what we're going to do is we're going to put everything that we have learned today into one single example. Now, we are going to create something called a grading system. Okay, so basically we will have 3 students with homework scores and final exam scores. Now, for the homework and final exam, we will have different weightage. Okay, and then basically using that weightage for each student, we're going to compute the final grade, final score. Okay. Now, why is this useful? And just like I mentioned, when you go for the site surveying, you will get a lot of values. Okay, you will get a lot of variables and their values. Now, you can use this example as your baseline or starting point to tweak the code to satisfy your requirements, to use your own equation. The example that I'm going to show you in 2.6 is a very simple addition and multiplication. Okay. So let's go ahead and do it. Now, of course, imagining this is a fresh canvas, okay, clean canvas. Now we're going to start with importing the PD, the pandas data frame. Of course, we need to use the numpy as well. So pandas data frame, PD, numpy as NP. Run it, no problem. Next, what we're going to do, in this case, I'm actually going to initialize the data frame, okay? But for you will have the Excel spreadsheet, right? The CSV file. Now, we learned how to read the CSV file, right? So you can just read CSV, okay? And then put it into the data frame. That easy, okay? But for now, for this example, I'm just going to create my own, okay? Because I do not, well, technically, I do have the CSV file that I created before, but it's gonna, for the sake of illustration, I'm just gonna show you how you can initialize. Okay. So let's have a name, and for the notes I have a Smith, King, and Martha. But you have to keep Alex the same name. Okay. Let's keep Alex, King, not King, Ben, and what was the last name? Casey, right? And then next column that I won was the homework, right? Homework score, yeah. Next column title is a homework score. And then inside I gave, of course, you can give any numbers that you want, but I'm just gonna follow my notes, 898, 76, 43, okay? And the last column that I'll have exam score, and exam scores will be 72, 72, 99, 92. Okay. My phone is quite big, it's running out of space. Let's see. That's how you initialize it. Let's see how it looks like when you print them. There it goes. Okay. So imagine that, well, I initialize a table. Imagine that CSV file is sitting in a file. Let's say you downloaded it, you imported it, okay? You loaded it, okay? Using the read CSV function. Now, next thing that you need to do is, a second, you need to define the homework weightage, and you need to define the exam weightage. Now we're gonna put 0.7 weight on the homework. That's epic. Well, we can do the reverse way, but for you have all the freedoms because you're the one who decides. Okay. Now we'll put that weight. Okay. And then what we're going to do I will do the homework weighted. You will notice that this is slightly different from the note that you will see, because the note that I have actually have that saving it and then reading it back. All the things are all included, but you can actually see this one is more simplified version. The one that I'm showing you is more simplified. Okay. So here, what I'm going to do is I need to get I'm actually calculating the weighted homework score. So what I need to grab is the homework score column. I need to grab that value. And what do we need to do? We need to multiply the weight, right? So I do that. Okay, let's print. Let's see what happens. There it goes. Hey, so we had 98, 76, 43, right? That's the homework score column. We grabbed it. We multiply the weight, 0.7. So that is the homework scores, right? Next, what we need to do is we have the exam weighted. It's same thing. We're gonna grab the data frame we created. We grab the exam score, and we do the same. Multiply exam weight. Okay, and then we can also print exam weight. Okay. Oh, sorry, weighted. Okay, so this is the exam weighted scores. Now, once you calculated the homework and exam, the weighted values, what you need to do is you need to calculate the final score equals what? The homework weighted plus exam weighted. Okay, you can check the final score. That's the final score right there. Okay, so you calculated. Now we started with this table, right? But this table does not have another column to indicate the final score. So what you do is we are going to add another column. So from the data frame student score, we're going to say, hey, let's add another column, say final score. And then you dump the final score. That's it. Okay. And then let's check. Hey, there it goes. Okay. So we started here, right? We calculated weighted homework score. We calculated weighted exam score. We added those two. We got the final score. Now, because the first data frame did not have the column to save the final score, we just added that, right? We dumped the value to that, okay? And then what we can do, we need to save this, right? So what was the function? To CSV. And we need to give my file name, new final score, something like this, CSV, run it. So in the folder, I'll have new final score CSV. I actually did not have this file. Okay, it just popped up. There it is. Okay. So that's how this pandas data framework. Okay. So today I actually went over a lot of functionalities within 2 hours without any break. Okay. So thank you for staying with me. All right. Now, because there are so many functions, this means that you actually need to review. Okay. Now, as I mentioned, there's a very big difference between you knowing these functions exist versus not knowing anything. Okay. Now, since you have gone through this example with me, now you have some idea. Oh, okay. So these things can be done. Now you're at a good starting point. If you're wondering how something should be done, you can always come back to this example and take a look. Okay. All right. So that's everything that I have prepared for today. Thank you, guys. Yeah. Can you go to the last line? Typing, not finished yet. Oh, sorry. This line? Yeah, so if you do have any questions, please do let me know. All right. You're more than welcome to type it on the chat box. If you want to have your mic on and ask questions, you can also do that as well. Any questions? No question means everyone can get 100 on your mic. Okay, I know. You just need to actually review it, need time to review and study yourself. So, yeah. Okay, so that's everything from me. Thank you.